Hello and welcome back to another video. In this problem, we're asked to prove that cosine is a continuous function. So for cosine to be a continuous function, that means that the limit as x approaches a of cosine of x is equal to cosine of a. And by exercise 63, we show that this is equivalent to saying that the limit as h approaches 0 of cosine of a plus h is equal to cosine of a. So instead, we are going to start with this instead of starting with this. And then if we prove this, then we have proved the original statement, and therefore cosine is continuous. So we can say that the limit as h approaches 0 of cosine of a plus h, the cosine of a plus h is equal to cosine of a times cosine of h minus sine of a times sine of h. Using the limit laws, this is equal to the limit as h approaches 0 of cosine of a cosine of h minus the limit as h approaches 0 of the sine of a times the sine of h. We can then use the fact that the limit as x approaches 0 of cosine of x equals 1, and the limit as x approaches 0 of cosine or of sine of x equals 0, by saying, okay, we have cosine a here. That could be pulled out of the limit because it doesn't have an h in it. So this is cosine of a times the limit as h approaches 0 of cosine of h minus sine of a, we can pull that out too, times the limit as h approaches 0 of sine of h. So this is equal to cosine of a times this limit we found is equal to 1 minus sine of a times this limit is equal to 0. So this is cosine of a times 1 minus sine of a times 0 is equal to cosine of a. And we know since we have proved that the limit as h approaches 0 of cosine of a plus h is equal to cosine of a, therefore the limit as x approaches a of cosine of x is equal to cosine of a, and therefore cosine is a continuous function.